All right, so we're asked to compute this line integral, and they tell us what c is. So I'm going to go ahead and just sketch a little picture of c just to make myself feel good about this problem. So it's the right half of this circle. We're starting down here at -4. We're going to go up to 4, and I guess I'll draw the whole circle. Hopefully the iPad will help me out. Yeah, that's pretty good. And then we can we'll do partial erasing, and we'll separate that, and then we'll do whole erasing, and we can just get rid of that side. Okay. And then it tells us we're starting down at 0 to -4, so we're going to orient that way. So you're starting here, and then you're going along up to there. Okay, so we're ready to go. I need to work this out. First thing I need to do is parameterize my curve. You should know how to parameterize a circle. So I can parameterize this as r of t equals, well, what do I want my x to be? I want x to be the radius times cosine t, so 4 cosine t, and then y is going to be 4 sine t. And I want the right half of the circle, so I want t to be between, what, minus pi halves and pi halves. So again, just to be clear, I'm saying x is 4 cosine of t, and y is 4 sine of t. And if you start from minus pi halves and go up to pi halves, you'll trace out the right-hand side of the circle. The next thing that I want to do is go ahead and compute what ds is. ds is the length of r prime of t dt. So let's do that. This is going to be, you know what, we'll just compute r prime of t right here. And I'm going to get minus 4 sine t, 4 cosine t. So the length of r prime of t is going to be, what, radical 16 sine squared of t plus 16 cosine squared of t. Well, gosh, that's just root 16, which is just 4. Whoops, and I dropped my dt's. The way that I wrote it, I need to keep my dt's everywhere, so let's write it like that. Root 16 dt, so this is just 4 dt. So that's nice. The length worked out pretty well there. So now we can say, okay, the integral that we want, which was, what was our function, xy to the 4th, the line integral of this function along c with respect to arc length becomes the integral from minus pi halves to pi halves. That's just your bounds on your parameterization. You plug your parameterization r of t, either thinking here or here, either one, same thing, into your function. So x now becomes 4 cosine of t, and y becomes 4 sine of t. So I get 4 sine of t to the 4th dt. Then I multiply by r length of r prime of t dt, which is just 4 dt. And so, wow, I get a lot of 4s. So this is going to be, what, 4 to the 6th integral minus pi halves to pi halves. I'm going to run out of room, so let's drop that right down there. And what do we get here? We get a sine to the 4th t times cosine of t dt. You should instantly know how to solve this, work this one out. I'll go ahead and tell you the tools, but I'm not going to work it out. So u is sine of t, du is cosine of t, and so you'll end up with just 4 to the 6th integral minus 1 to 1 of u to the 4th du. If you go ahead and change the bounds, some of you don't like to, that's fine. Either way, you're going to work this out, no problem, and you're going to get 2 4 to the 6th over 5, so 2/5 times 4 to the 6th. Yes, you can evaluate that if you want to. I didn't really want to, so I just left it like that. I guess I could write it as 2, this is 2 to the 12th, 2 to the 13th over 5. That's probably better than leaving it 2 times 4 to the 6th. 4 is 2 squared, yeah. Okay, so that's that one. Let's stop this video here, and then we'll go on.